Many shipping companies are struggling to ensure safe, profitable, and efficient cargo operations on board tankers. The operation is strongly influenced by the cargo monitoring system, which must be designed to weather even the most severe conditions in the tanks, and to alert the crew when problems start to develop. We want to take you inside the tank for a better understanding of all the critical conditions that can impact the measurement. That's why we say reliability above all. The principle of all tank radars is to measure the distance from the unit down to the liquid level that is visible for the radar beam. In an empty tank, there is only one echo, and that is the flat tank bottom. This is a strong echo, and it is simple to measure against, therefore the green color on the difficulty meter. When a new tanker is built, it is common to test the radars against water with high reflectivity and when the liquid is stationary. Comparative tests with the radar against a manual sounding are done during trials in the shipyard and at sea. Measuring against real cargoes, other than water, is more critical. Loading a liquid like oil means that the measurement becomes more difficult because the oil absorbs much of the radar energy and only a little is reflected. Loading or unloading a tank can cause turbulence in the top layer of liquid. The radar also needs to track a moving target, requiring a combination of responsiveness and accuracy. Topping up a tank is critical, and most radars are vulnerable to be disturbed by other echoes in the near zone. The antenna itself and the deck socket may give conflicting echoes. When stripping a tank to completely empty, radars can have difficulties in measuring. The strong bottom reflection from the metal starts to conflict with the radar echo from the liquid. When the ship is operating with a trim and list, the liquid target is no longer at a 90-degree angle towards the radar. The reflection will not come back straight at the tank radar. Much of the returned echo will miss the antenna on the way back. Marine tanks can have a layer of foam on top or turbulence. This depends on cargo and operating conditions. This layer can conflict with the liquid surface, making it harder to detect the true liquid surface. When the ship rolls and pitches in the ocean, or even from heavy seas, waves of several meters height can roll back and forth in a tank, making the radar-emitted energy bounce off the waves in unwanted directions, reducing the returned echo strength and moving the liquid level. Depending on the cargo and the operating conditions, the antenna parts inside the tank can become dirty and impact the radar signal twice, both on the transmitted and received signal. Humidity in the tank can form a water film and drops of water on the inside of the tank roof and on the antenna, impacting the radar signal twice, both at the transmitted and received signal. When designing the tank, it can be necessary to locate heating coils, ladders, and pipes within the radar beam area, causing radars to lock onto the disturbance echoes instead of the liquid. Atmospheric changes in temperature can influence the measurement and heavily impact the radar accuracy. Some instruments perform well at room temperature, but are less accurate in heat or cold. It is easy to imagine what will happen when several or even all of the disturbing elements affecting the cargo monitoring system are combined. Sounds difficult? Luckily, there is a solution to ensure safe, profitable, and efficient cargo operation. Uptime and reliability, measurement accuracy, high safety, onboard diagnostics, instrumentation scope, compliance, maintenance and service, lifetime support. Introducing a new generation of marine tank radar gauges. Visit us at emersonprocess.com/MTM.